Let's talk about something every creator or business owner dreams of. In this video, I'm going to walk you through how to auto-post to social media platforms like Facebook or Twitter using the power of n8n automation and AI. Totally unlimited once you're a member of the n8n Launch Premium community, thanks to our custom n8n Launch API. And the best part, you can source content from anywhere, like a news API or even a simple Google Sheet. Let's get into it. We'll start with a blank n8n workflow and then head over to the newsdata.io website to sign up for an account and grab our free API key. After signing up, go to your dashboard, find the API key section and copy it. That's the key we'll use to fetch the latest news. Now, before we jump back into n8n, take a second to explore their pricing. They offer a free plan that lets you grab up to 20 news articles per day, which is more than enough for solo creators or small businesses. You can also plug in your own data source, like a spreadsheet, if you prefer. Let's keep things simple and stick with the news data free plan. Back on the dashboard, go ahead and build your custom query. Start by typing a keyword or phrase into the search box. Anything you want to explore articles about, the platform will instantly generate a query URL for you based on that input. From there, you can easily fine-tune the results by filtering for specific categories, countries, or even languages, depending on what best fits your target audience or business niche. Once that's ready, copy the generated URL and paste it in your browser to preview the JSON data. Boom, you'll see a list of the latest articles in clean JSON format. Now, let's bring that data into n8n. Drag in a schedule node. This is how we tell n8n when to run the automation. You could set it to every hour, daily, or whatever suits your content strategy. Next, add a HTTP request node and paste in the news query URL. Hit test step. And just like that, we've got a live feed of fresh articles. But we don't need all of that raw data. We only care about the first, newest article. So we'll add a set node or edit fields node to extract just the first item from the results array. Let's name this new field article, and since it holds multiple pieces of information, we'll structure it as an object. Inside that, instead of keeping the full list of articles from the query URL, we'll just grab the first result, the most recent one. Hit test step, and now we've successfully extracted the latest article from the query. Clean, simple, and ready for the next step. Now comes the magic. Let's transform this raw article into a social-ready post using AI. Most people would normally set this up with two nodes. An AI agent node connected to a chat model like OpenAI. In that setup, you'd pass your prompts, the system message and user message, into the AI agent node. Behind the scenes, that node just sends a request to OpenAI's API and returns the result. That's exactly what the n8n Launch Text Generation API does too. Now, the AI agent node is great when you're building something more advanced, like an AI chatbot that needs access to tools, databases, embeddings, or memory. But in our case, we just want to send prompts and get responses. Simple, clean, and fast. So instead of stacking multiple nodes, we're going to streamline it. Just use one HTTP request node to call the API directly. And normally, this would mean setting up OpenAI credentials and managing cost. But we've already handled all of that for you. Everything's pre-packaged inside the n8n Launch API. One call, unlimited usage. Now we're going to take that title and description from our latest article and use it as the input body for the text generation API call. The goal? Turn that raw article into a polished, engaging post, something you'd proudly publish on Facebook, Twitter, or anywhere your audience hangs out. To do this, let's first import the curl command for the text generation API from the n8n Launch docs. Just like before, we'll grab the body template, which includes the system and user role structure. Now for the fun part, writing the prompt. In the system role, we'll guide the model. Something like, you are a professional copywriter for social media. Your job is to take raw news headlines and turn them into concise, engaging posts. Then in the user role, we'll pass in the actual article title and description from our earlier step. Just drag and drop them from the node output. That's it. This gives GPT-4 the context it needs to write something truly engaging. The model should be OpenAI. Alright, let's test it. Alright, make sure to fill out your XAPI key in the header before hitting that test button. That's how we authenticate the request with 0 to launch. Awesome. Look at that, a perfectly rewritten post. It's catchy, engaging, and crafted to grab attention on social media. And the best part, you didn't write a single word yourself. The AI did the heavy lifting, transforming raw news into something ready for your audience to connect with. Now that we've crafted the text for our social media post, we want to pair it with a compelling image. Because let's face it, visuals are what stop the scroll. So here's what we're going to do. We'll use the text generation API again. But this time, not to generate a post, we'll prompt it to extract 5 relevant keywords from the post we just created. These keywords will become the input prompt for our image generation. Let's drag in a new HTTP request node. Just like before, we'll copy the curl command for the text generation API from the 0 to launch docs. Paste it into the node's curl importer to quickly fill in the structure. Now tweak the prompt. Keep the default system role if you'd like, or update it. Then in the user message, tell the model something like, from the text below, extract 5 visually descriptive keywords suitable for image generation. Then drag in the post content from the previous node. That's your input. Make sure to drag the post content into the right spot in the user message. That's what the model will use as context. Once that's done, double-check that the model is set to OpenAI. Alright, everything looks good. The structure, the prompt, the model. Alright, we need to set the XAPI key in the headers. Hit test step again. Perfect. We've now got a short focused list of keywords pulled directly from our article. These are tailored to the topic and perfect to use as a prompt for the image generation API. Now we've got a visual concept. Time to generate the image. Use the 0 to launch image API with another HTTP request node. Import the curl. Fill in the key and pass the keyword list into the prompt field. You can set the width and height here. Use the Flux model for high-quality outputs. Hit test. And there it is. A perfectly styled image for your post. Now we have both engaging text and a matching image, ready to post anywhere. Let's tidy up by renaming your notes. Title them clearly. Get news. Summarize for social, extract keywords, generate image, and so on. Looking at the workflow now, it's lean, powerful, and completely automated. Compared to the typical setup using an AI agent node along with a separate model node, our workflow here is much simpler. We've reduced the clutter, fewer nodes, cleaner lines, and yet it still delivers the exact same result. Everything happens in a single HTTP request node. We send the prompt, receive the response, and handle the logic all in one place. That means our workflow is not only easier to manage, but also more scalable and tidy, especially as we continue to add more features or expand automation later on. Now that we've generated both a compelling post and a beautiful image, It's time for the final step, actually publishing that content to Facebook. Let's make a smooth transition into setting up your Facebook credentials so you can start auto-posting directly to your page using n8n. First, head over to the Facebook developer website. If you haven't signed up as a developer yet, don't worry, just register using your regular Facebook account. Once you're in, click on My Apps, and you'll see a dashboard of any existing apps you've created. Let's go ahead and create a new app specifically for this automation. Enter your app's name and your contact email address. Choose Other as the use case, and when it asks for the app type, go with Business. Then hit Create App. After that's done, we'll land in the app dashboard. Here, under Settings Basic, we'll fill out a few details. The one field you'll need to pay attention to right now is the privacy policy URL. To get this, we'll use a free service. Just search for Free Privacy Policy Generator. Select App as the platform, continue through the steps, and fill in basic details like the app name. Let's say n8n. Complete the remaining fields with your app details and click Next to continue. To keep things simple, just select Email when you're asked about the type of personal information your app collects from users. Enter your email address and click Next to proceed. We choose this option to generate a free privacy policy without any cost. Enter your email address and hit Generate. Boom! You've got a working privacy policy link. Copy that and paste it into the Facebook app settings. Now scroll down and choose a category. We'll go with Business and Pages. Save your changes and then flip the switch to make your app live. Next up, go to Tools and select Graph API Explorer. Here's where the real connection happens. In the top drop-down, choose the app we just created. Then, under User or Page, select the Facebook page you want to use, for example, my 02 launch page. Next, select the Facebook page you want to set up its access token, then start assigning permissions to your app. Specifically, choose Pages Manage Metadata and Pages Manage Posts. That's because we need this access token to grant permission for managing the page and publishing posts on it. Then hit Generate Access Token. Once you're done, Facebook will give you a token. But hold up, we want this token to last. So head over to the Access Token Debugger, paste it in, and hit Debug. You'll see that by default, it's short-lived, usually about an hour. We're not about that life, so scroll down and click Extend Access Token. This will give you a long-lived token, usually valid for 2 months. Confirm by debugging the new token again. Great, now we're ready to use this in production. Let's head back to our n8n workflow. After our text and image generation is complete, it's time to upload the post. Drag in a Facebook Graph API node and place it right after your image generation step. Then let's create a new credential. Paste in your access token, save the credentials, and give them a name like 02 Launch Page Access. Also rename the Facebook node, give it a clear, descriptive name so your workflow stays organized and easy to follow. Now let's configure this node to actually publish content. Set the HTTP method to Post and select the latest Graph API version, whichever is currently recommended. Next, under the Facebook Graph API node settings, set the node field to Me. This tells Facebook you're interacting with the page or user connected to the access token. In our case, the page we authenticated earlier. Then, for the edge, type Photos. This specifies that we want to post a photo to the page's timeline. Facebook calls these endpoints edges in their Graph API, and Photos is the one we need to upload an image. Now let's enable the Send Binary Data option. This is key, because the image we generated earlier is returned as a binary file. By default, the file is named Data, so in the binary property field, we'll just type data to match. Alright, everything's ready. Let's hit Execute Previous Nodes to rerun the full workflow. This will fetch a fresh article, rewrite it as a social post, generate a relevant image. Now that the image part is done, we need to pass along the article post text that our LLM crafted earlier. This is what will show up as the caption for the image on your Facebook page. To do that, scroll down and add a query parameter named message, then simply drag the formatted post text from the earlier node, the output of the text generation API, into the value field. This way, when the image is posted, it'll appear with a clean, engaging caption written by AI, tailored from the latest article. Now, we're ready to test the full post to Facebook flow in action. Hit test step, and boom, we got an ID and post_ID in the response. That means the post was successfully published to your Facebook page timeline. Let's hop over to the page and take a look. Awesome. Our AI-generated article, complete with a custom image and catchy caption, is now live for your audience to see. Now, to keep this automation running 24/7 and auto-posting based on the schedule we set earlier, all we have to do is toggle the workflow to active. That's it. From here on out, your social feed runs on autopilot. And just like that, you've built a fully automated system that fetches trending news, rewrites it with AI, generates a custom image, and posts it straight to your Facebook page. Totally hands-free. This is the power of no-code automation with n8n and the flexibility of 0-to launch APIs. If you enjoyed this tutorial and want to go even deeper with AI workflows, come join us in the 0-to launch community on School. Links in the description. I'll see you inside. Hey guys, welcome back. Let me walk you through a scenario that might sound familiar. Imagine a growing company that needs to train new employees, support customers, or help internal teams quickly find answers about policies, procedures, or product features. Or you're visiting a travel website, and instead of digging through pages of info, you can just ask a chatbot questions like, do I lose access right after I cancel? And it instantly answers, straight from the company's official docs. In this video, I'll show you step-by-step how to make this chatbot production ready and integrate it into any website like this one. Before we jump into the setup, quick heads up. If you're into building with n8n, AI agents, or automation tools, you'll definitely want to check out my 0-to launch community. It's a free space I built on School for people who want to go from zero to launching real automations. Whether you're just starting or already building advanced workflows, you'll get step-by-step AI automation tutorials, pre-built templates from videos like this one, and real support from real builders. Plus, every resource I mention in this video, including the scripts, links, and tools, will be posted directly inside the community. Come introduce yourself, ask questions, and grab the tools you need to build smarter and faster. Links in the description. Alright, back to the setup. Normally, that would require someone who's already familiar with the internal documentation, maybe a senior staff member, a manager, or a live chat support agent. But here's the problem that takes time, money, and a lot of manual effort. And as the business grows, that knowledge gap grows with it, making it harder and harder to handle everything manually. That's where AI can make a big impact. What if you could build a chatbot that acts like a professional trainer or support agent? Someone who's read all your documentation and can respond to questions naturally, anytime, 24/7. Well, in this video, that's exactly what we're going to build. But before we dive in, let's make sure your n8n instance is ready to go. Whether you're using the cloud version, running it locally, or hosting it on a VPS, the steps in this video will apply to all setups. Before we dive into building it step by step, let's explore the tech behind the scenes. We're going to break down everything you need to know about how this works. So whether you're technical or not, it'll all make sense. This isn't just about copying steps. It's about actually understanding what's happening, so you're not just running commands like a machine, but building like a real automation architect. So how do we actually make this kind of smart assistant a reality? One that doesn't just spit out generic answers, but gives real useful responses based on your company's own documentation. To do that, we need to combine two powerful things: your data like training manuals, policy docs, or product FAQs in a language model like ChatGPT or Claude. But here's the key. We don't just throw your documents into the AI and hope for the best. Even though AI models are smart, they're not magic. They can't just take a huge document, instantly understand it, and remember it forever like a human would. Language models like ChatGPT don't work like humans. They can't just read a full document and remember it forever. Models can only handle a limited amount of text at once. It can't scroll or browse through files. It only sees what you give it right now. So what's the solution? This is where RAG comes in. RAG stands for Retrieval Augmented Generation, and it acts as the bridge between your unstructured data and the LLM. LLMs, like ChatGPT, aren't built to read through entire files or documents. They work best when you feed them just the right information in a clean, structured format. So with RAG, we handle all the prep work before the LLM sees anything. That means taking your messy, unstructured documents and transforming them into something the AI can actually understand. Let's just start with the first step in that transformation, splitting your document into smaller, searchable chunks. Think of it like turning a textbook into flashcards. You can't memorize the whole book, but if you organize the key ideas, you can pull up the right info exactly when you need it. This is the first step toward making your documents AI readable and searchable. Now that we've split your documents into smaller chunks, the next challenge is, how do we search those chunks? Not just by exact words, but by what they mean. Why keyword search isn't enough. Let's use an example. Imagine you're on Netflix, and you want to find a movie, but you don't remember the title. You type something like, that sci-fi movie where the guy wakes up over and over again on the battlefield. If Netflix only used keyword search, it would try to match your words exactly. So unless you type the exact title, you'd get nothing. But what you're really doing is describing the meaning or concept behind the movie. That's what most real-world questions are like, especially when people use natural language. What's the refund policy for annual subscribers? How do I reset a user's password? These kinds of questions are not easy to answer with keyword matches. They're too human, too nuanced. The solution? Search by meaning instead of words. And that's where embeddings come in. Embeddings are a way to translate a chunk of text into a vector, a list of numbers that represents the meaning of that text. Then when someone asks a question, we also turn that question into a vector. And now instead of doing a simple word match, we can compare the two vectors mathematically to see which document chunks are most semantically related to the question. This lets the agent find and use the right context, not just guess. In short, embeddings turn your text into math that captures meaning. This makes it possible for AI agent to compare, search, and retrieve the right answers based on what things mean, not just what they say. Now that every chunk of your document is turned into a vector, we need a smart place to store and search them. That's where a vector database comes in. What is a vector database? It's a special kind of database designed to store embeddings and quickly find the ones that are most similar to a new input. Let's say someone asks, how do I update my billing info? We convert that question into a vector. Then we ask the database, which chunks of our documents have a vector closest to this one? The database compares how close the meaning is and returns the most relevant matches, even if they use totally different words. To compare meaning, it uses math, specifically something called cosine similarity. If two vectors point in almost the same direction, that means they're very similar. But if they point in opposite directions, they're not related at all. This lets the LLM like OpenAI chat model match questions to the right answers in your data based on meaning, not just keywords. So now we know how vectors work and how we compare them based on meaning, not just words. Here's the next step. We need a place to store those vectors and search them in real time when someone asks a question. There are several great services that provide vector storage and search capabilities. In this tutorial, we'll be using Pinecone for a few key reasons. It's cloud-hosted. No server setup required. It has a generous free tier, perfect for testing in small projects. and it integrates easily with tools like OpenAI and n8n. All we need is a free Pinecone account and an API key, and we're ready to store and search vectors in real time. Now that we have broken down each piece from document chunks to embeddings to semantic search, let's look at how it all works together behind the scenes. This is the full RAG loop, short for Retrieval Augmented Generation in action. First, we take your document and split it into smaller chunks, like paragraphs or sections. Then we use OpenAI's text embedding API to convert each chunk into a vector, a math-based representation of its meaning. Those vectors are stored in a vector database, like Pinecone. Now, when a user asks a question, for example, how do I change my billing method? That question is also converted into a vector using the same embedding model. That vector is then sent to Pinecone, which compares it to all your stored document chunk vectors. Using cosine similarity, it finds the chunks with the closest meaning, even if the wording is totally different. Those relevant chunks, along with the original question, are passed to a language model, like GPT-4 or Claude. Finally, the model generates a smart, helpful answer in natural language based on your data, not just guesses from general training. Now, let's make this real. To build this system, we first need a vector database to store our content. All right? Let's set up our vector database using Pinecone. Head over to pinecone.io. Click Sign Up and create your account. Once you're in, you'll see your API key, copy it, and save them somewhere safe on your machine. You'll need it when we connect Pinecone to n8n. Next, we need to create a new index. This is your actual vector database. Give it a clear name like knowledge base or chatbot RAG. Then choose your embedding model. For this demo, we'll keep it simple and select OpenAI text embeddings, small model. So what's the difference between small and large embeddings? It comes down to dimensions. When we say dimensions, we're talking about the number of values in each embedding vector. Each dimension is like a feature or coordinate that helps represent the meaning of the text. Higher dimensions can capture more detail and nuance, but they take more space and more time to search. For now, small is fast, free, and great for most use cases. Now let's talk about metrics, how Pinecone compares vectors to find the best match. By default, we use cosine similarity, the method we just explored a moment ago. It compares the angle between two vectors, and if they point in a similar direction, it means they carry similar meaning. There are other metric options too, like dot product is like multiplying two vectors together. A higher dot product between the query vector and a document vector means they point in a similar direction, so the query and document are likely related in meaning. It gives a higher score when both vectors have similar values in the same places. Dot product is useful in many machine learning applications, especially when the magnitude of vectors carries meaning. But for semantic search, cosine similarity is the most commonly used method. So why is cosine similarity the most commonly used method in semantic search? It comes down to what we care about in a chatbot or RAG system. Semantic, meaning not the length of the text. When we embed a document, whether it's a sentence or an entire page, that vector carries two things. One, its direction, which captures the meaning. Two, its length, which reflects how strong or confident that representation might be. Cosine similarity focuses only on the direction of vectors. It measures the angle between them. So even if two vectors are different lengths, if they point in the same direction, they represent similar meaning. In embeddings, that direction is what carries semantic information, which is exactly what we need when matching questions to answers. On the other hand, dot product takes both direction and length into account. That can be helpful when magnitude matters, like in certain ranking models or confidence scoring systems. But for comparing pure meaning, we usually don't care how strong or long a vector is. We just care if it's pointing to the same idea. That's why cosine similarity is preferred for matching questions to answers, finding related chunks of text, and building RAG or semantic search systems. It gives us comparisons based on meaning, without being skewed by vector size. So now we know why cosine similarity is the go-to for semantic search. With that set, we're almost done setting up our vector database. Next, choose a cloud provider. Choose any option is fine here for testing. Then pick a region close to your app or user base. For this tutorial, we'll stick with the free tier. That's the starter plan. Then click Create Index. Just like that. You've successfully created your vector database. Right now, it's still empty. But in the next step, we'll use n8n to send data into this index. Alright, let's head back to n8n. Before we build the full workflow, we need to prepare the document we want to process. In this example, I've already uploaded a document to Google Drive. You can do the same. Just make sure it's accessible from your account. Next, we need to connect n8n to Google Drive so it can pull in the document automatically. To do that, we'll create a Google Client ID and client secret from the Google Cloud Console. These credentials let n8n authenticate with your Google account and securely access your Drive data, like downloading files into the workflow. Head over to Google Cloud and log into your account. If you don't already have a project, click Create Project and give it a name, then hit Create button. Then go to your project's dashboard and open APIs and Services. Click Enable APIs and Services. Search for Google Drive API. Click it and hit Enable. Once the Google Drive API is enabled, we're ready to generate the credentials that n8n will use to connect. The access type should be user data. Alright, hit Next. Now you'll name your app and fill in your developer and support email. Click Save and Continue. Save and continue again. Now we'll create the actual credentials. Choose Web Application as the app type. Give it a name like Chatbot RAG. You'll see fields for Authorized JavaScript Origins, Authorized Redirect URIs. We'll leave these blank for now because we'll get that redirect URL from n8n in a moment. Click Create. Now you'll see your new client ID. Click Done to finish setup. Next, go to the Credentials tab. You'll see your new web application listed with its client ID. Click the Edit icon to open it. Here, you'll find both your client ID and client secret. These are the credentials we'll use in our n8n workflow to authenticate with your Google account. Alright, let's head over to n8n. Log into your account and create a new workflow. Give it a clear, meaningful name. Start by adding a manual trigger node. This lets you run the workflow with a single click while testing. Then add a Google Drive node as the next step. Set the action to Download File, since we want to pull a document from your Google Drive. To connect Google Drive, we'll need to authenticate this node. It'll show a redirect URL. Copy this URL and paste it back into your Google Cloud App settings under Authorized Redirect URIs. Now, paste your client ID and client secret into the authentication fields. Before clicking Sign in with Google, we need to push the app to production to avoid access errors. In the Audience tab, click Publish App. Now return to n8n and click Sign in with Google. Select the same Google account used to create the credentials. You'll get a warning, but that's okay. This is your private n8n setup. Allow full access to your Google Drive files and hit Continue. And just like that, you're connected. You should now see your Google Drive files listed in n8n. Alright, let's select this file. This is the exact document we stored earlier on Google Drive. Alright, to keep things simple, we'll use the Pull by URL option here. It will automatically switch to the document URL field. We've got our file selected and everything is connected, credentials, access, and the node setup. Now let's test the workflow to make sure we can download the document from Google Drive successfully. Click Execute Node or Test Workflow and watch n8n pull in the file. And just like that, we've downloaded a file directly from Google Drive. Now we're ready to process and store that document in our vector database. Pinecone. Let's add a new node to the workflow. Select the Pinecone Vector Store node. Set the action to Add Document to Vector Store. To connect to Pinecone, we first need to add a new credential. Here, we paste in your Pinecone API key, the one we saved earlier when we signed up. Once connected, you'll see the list of your indexes. Select the index you created earlier. You might see an error because this node also needs an embedding model to convert the text into vectors. We already selected OpenAI Text Embedding, small model, when we created the Pinecone index. So let's use the same model here. Again, we need to create a new credential. This time for the embedding node, grab your OpenAI API key and paste it here to connect to your OpenAI account. Then hit Save. We leave the embedding model as the default text embedding small, the same model we selected earlier when creating the index in Pinecone. This keeps everything consistent between n8n, OpenAI, and Pinecone, and ensures that everything is aligned and works perfectly. Before we run the OpenAI embeddings node to convert our file into vectors, we need to tell n8n how to load the document data. This step is required by the Pinecone Vector Store node. So let's add a Document Loaders node. You'll see two options. Since we're not loading anything from GitHub, we'll stick with the default file loader. Our file is a doc file stored as binary, so under Data Type, select Binary. We'll keep the default settings, load all input data, auto-detect the file format, which is great for handling different doc types automatically. Okay. Now here comes a really important part. We need to split the text into smaller chunks before sending it to the embedding model. Why do we split the text? Because AI models like GPT can't process huge blocks of text all at once. Think of it like flashcards. You break a big book into smaller pieces, so the AI can understand one piece at a time and still keep the meaning clear. This is handled by something called a text splitter. You'll see three types, but for this tutorial, we'll choose the recursive character text splitter. What's a recursive splitter? Don't worry, it sounds complex, but here's what it really means. It tries to split the text at natural points, like paragraphs, sentences, or even spaces. Instead of cutting things off in the middle of a thought, if it can't find a paragraph, it looks for a sentence. If no sentence, it looks for a word. That's what recursive means. It works from big chunks down to smaller ones. It's the most recommended option when your text varies in length and structure, like documents, articles, or support manuals. So we've selected the recursive character text splitter. Now let's move on to the next part, setting the chunk size and chunk overlap. Two key settings that control how the document gets broken down. What is chunk size and why does it matter? This specifies the target length for each chunk. When we split a document for AI processing, we break it into smaller parts called chunks, kind of like dividing a long book into flashcards. The chunk size controls how big each flashcard is, measured in characters, not words. For example, a chunk size of 1,000 means each chunk will contain about one long paragraph or a few short ones, roughly 150 to 200 words. Why that number? Because large language models like GPT have a limit on how much they can see at once. This is called the context window. If we send chunks that are too big, we may hit token limits, losing performance or skipping important content. But here's the clever part. If the chunk is still too long, the splitter will call itself again, recursively, to break that big piece into smaller ones. This is what makes it different from basic splitting methods. The recursive splitter is smart. It keeps trying to split content in a way that preserves meaning and flow without cutting sentences or ideas in half. So in simple terms, if the content fits inside the chunk size, it's great. Keep it as is. If it's too long, split it again until it fits. Repeat this process recursively until every chunk is clean and manageable. But if we send chunks that are too small, the AI might miss the context of the message. That's why the default 1000 characters works great for most documents. Next is chunk overlap. Now you might be wondering, why would we want chunks to overlap at all? Well, here's the deal. When we split a document into chunks, sometimes a sentence or important idea ends up right at the edge, cut off between two chunks. That's a problem, because the AI might not get the full meaning if half the sentence is missing, so instead, we add a little overlap between chunks, like having the last bit of one chunk repeated at the start of the next. This keeps the context flowing smoothly and makes sure nothing important gets lost during the split. Why 200? 200 characters is about 1 to 2 sentences. That's usually enough to carry over full thoughts, transitions, or headers that might otherwise be cut off. It's a great starting point, especially for longer paragraphs or structured docs. Now that we've configured the chunk size and overlap, our document is fully prepped and ready to be embedded. The next step is to test the workflow and watch it convert our document into vector format using OpenAI embeddings. Then push that data into our Pencone index. Click Execute Workflow or Test, and n8n will run the full flow, from loading the file to splitting it, embedding it, and sending it to Pencone. Once it finishes, let's head back to our Pencone dashboard and open the index we created earlier. Inside, you'll now see a list of vector entries, each one representing a chunk of your original document. You've now seen the full pipeline in action. The document was split into chunks. Each chunk was embedded into a vector, then stored inside Pencone, your vector database. Through this process, the meaning was preserved, and now your content is fully searchable and ready to power your RAG system. With everything set up, we're ready to build the actual chatbot workflow, where users can ask questions and get answers. Now let's head back to n8n and start building our chatbot workflow. The part that talks to users will start by adding a chat trigger node. This listens for incoming user input like a message in a web chat or API request. But here's something important to keep in mind. We only need to process and embed our document once. Since all the vectors are already saved in Pencone, there's no need to re-upload or reprocess the file every time the chatbot runs. To avoid duplicating data, make sure to keep your chatbot logic separate from the document processing workflow. You can either create a new workflow just for the chatbot or build the chat flow in a separate path from your existing nodes. This way, the chatbot only talks to Pencone, where your document vectors are already stored and ready to use. This chatbot will be built around a Q&A flow. The user asks a question and the system returns a smart, human-like answer. So next, let's add the question and answer chain node. This node handles the logic of pulling relevant context and generating a response. For this tutorial, we'll use OpenAI's chat model as our LLM, but you can swap in any language model you have access to, like Claude, Cohere, or even a self-hosted LLM. Just make sure to connect your OpenAI account by pasting in your API key as a credential. Now that our chat OpenAI node is ready and connected, let's complete the rest of the Q&A pipeline. Next, the question and answer chain requires a retriever node. This is what actually connects to our stored vector data. So let's add a vector store retriever node. Inside this node, we'll keep the limit parameter set to the default. That means when the user asks a question, the system will return the top 4 most relevant chunks from Pencone. Based on meaning, not just keywords, or in simply term, this is the maximum number of results to return. Then we specify which vector store we want to use, and in our case, that's the Pencone vector store we set up earlier. Again, make sure to use the same credentials you created before. So the retriever has access to your index and all the embedded document data. Pencone also needs to know which embedding model you use to create those vectors. So here, we select OpenAI's text embedding small to match what we used when we uploaded the document to Pencone. keeping the embedding model consistent is critical. It ensures that your question vector and your document vectors speak the same language. This part of the workflow may look similar to when we first processed the document, but now we're doing something very different. We're not uploading any files or converting new data. Instead, here's what's happening. The user's question is first converted into a vector. That vector is sent to Pinecone, which searches your document index for the most relevant chunks. Those chunks are passed to the LLM, which uses them as context to generate a smart, natural response. And just like that, we've successfully built a simple yet powerful RAG system. Now let's test the chatbot in action. We'll start by asking a question based on the document content, and boom, we get a response that pulls the exact information we embedded earlier. Before we test the next question, let's scroll down to the data privacy section in the document to see what kind of info we expect the chatbot to retrieve. Here it is. It mentions that user data is encrypted, and for any privacy inquiries, there's a contact email listed right here. So let's try asking the chatbot and see if it can retrieve that exact detail from the document. This time we're testing if the AI can pull the contact email from the data privacy section of the document, and yep, it nails it. We get the exact answer from that section. Now let's push this chatbot to production mode, so anyone can access it 24/7 and ask questions from your document. To do that, we go back to the chat trigger node and enable the toggle to make it public. This gives us a webhook URL that will listen for user input and respond in real time. But to actually go live, we also need to activate the workflow. So let's toggle the workflow itself, and it's now live. Now, refresh the public webhook URL, and you'll see the interface for your chatbot. Let's ask it a quick question again. And just like before, it responds perfectly, pulling data directly from your document. One thing you might notice, right now the chatbot's answer includes the word response in front of the text. It works, but it doesn't look very friendly. Let's clean that up using a code node. This node will run right after the question and answer chain, and we'll use a bit of Python to clean up the output. n8n gives us a built-in variable called input, which holds a list of response objects in JSON format. Right now, it includes key value pairs like response and its text. To fix that, we'll create a new variable called results and extract only the raw text from each item. We loops through each item in input, accesses the result with item.json.response, then adds that to a new list of clean text only. Finally, we returns that list as results. Now let's run the workflow again and check out how the response looks. And now, the chatbot responds with a clean, friendly message, no extra keys. Before you go live, don't forget to save your workflow so everything stays active when users interact with the public chatbot. Let's do one final test. Ask a question and make sure the chatbot responds with a clean, readable answer. Looks great. Everything's working as expected. Now, let's personalize the chatbot's initial greeting. Go back to the chat trigger node and scroll to the initial message section. For this tutorial, we'll also leave authentication turned off so that anyone can access the bot freely. Here, you can change the welcome message to anything you like. Hit save. Refresh the chatbot page. Just like that. Your chatbot is now live, and it greets users with your very own custom welcome message. It's the perfect first impression for anyone asking questions. That's it. A fully working, document-aware AI chatbot powered by n8n, Pinecone, and OpenAI, live and ready for real users. But before we wrap up, I've got a special bonus for you, something that most tutorials don't show. Let me walk you through how to make your chatbot production-ready and embed it directly into any website, just like the travel site I showed you at the beginning of this video. I've already prepared a sample HTML landing page. This is a simple homepage layout that we can use as a starting point. If you have your own website, Just open your main HTML file like this. The next step is to embed the chatbot in the bottom right corner of the page. To do that, first, add the n8n chat styling CDN inside the head tag of your HTML page. Next, add a script tag at the bottom of your page. This loads the chatbot widget and connects it to the webhook URL from your live chat trigger in n8n. And remember, this webhook URL should be the same one used in your chat trigger node inside n8n. Under trigger mode, change it from hosted chat to embedded widget. This tells n8n to serve the chatbot as a widget that can be embedded directly on your website, instead of opening in a separate page. Make sure to save your workflow in n8n so the new settings take effect. Then head back to your HTML script. Here's where you can customize the entire chat UI experience. You can edit everything from the initial welcome message, the chatbot title, a helpful subtitle, and the placeholder in the input field. Once you're done, save your HTML file, then refresh your web page, and just like that, your chatbot appears as a polished widget ready to chat right from your site. You'll see your custom title, subtitle, and placeholder text exactly as we configured it. Let's test it by asking a real question. And just like before, the bot pulls the answer straight from your documentation. And that's it. You've now built a fully working RAG-powered AI chatbot, connected it to your docs, deployed it, and embedded it into a real website. If this video helped you, give it a like. Subscribe for more tutorials on AI agents, automation, and self-hosted tools. And drop a comment if you have questions or want help with your setup. And don't forget, all the resources, scripts, and help are waiting for you in the 02 launch community on School. Join for free and start building with us. Until next time, build smart, automate better, and I'll see you in the next one. Hey everyone! In the last video, we built a chatbot that could chat with a document file using RAG and Pinecone. If you haven't seen that yet, definitely check it out. It lays the foundation for what we're about to build. But in this video, we're going to upgrade that flow. Instead of just chatting with plain text documents, we're going to build a chatbot that can search and respond from table data, like a spreadsheet or Google Sheet. This is huge because so many businesses use tables to store their data, tour companies listing destinations and prices, e-commerce stores tracking product reviews and ratings, internal teams managing inventory or customer info. And now we can turn those tables into something users can chat with, using text or even voice commands. Imagine this. A user visits your website. They type a question into the chat widget. Instantly, your bot retrieves the right information from a live table and even shows them an image from the data. Or maybe they're on the go. They send a voice or audio file to your Telegram bot. In seconds, your AI agent transcribes it, searches your data, and responds back with a natural-sounding voice message. What is included in the Desert Adventure Tour? The Desert Adventure Tour in Egypt includes some great perks. You'll enjoy a stay at a 5-star hotel, local transportation, and airport transfers. Sounds like an exciting adventure. Yep, all fully automated. And in this video, I'll show you exactly how to build it from start to finish using n8n, Pinecone, and your own data. Let's dive in. So now that we understand the big picture, let's jump into the build and reuse what we've already created. We're going to start by duplicating our previous chat with documents workflow because it already has most of the structure we need. Give the new workflow a meaningful name. Hit duplicate. Now that our new workflow is ready, let's bring in the table data we want the chatbot to work with. First, we need to grab our table file, which is a spreadsheet stored in Google Drive. Make sure your Google Drive credentials are already set up. Then from the file list, find the one labeled Tour Data. That's the sheet we'll be embedding. Before we move on, let's go ahead and click the test step to make sure we can successfully download the file from Google Drive. Once we confirm that the file is pulled in correctly, we're ready for the next step, creating a new Pinecone index to store our table data and power the chatbot's memory. Head to the Pinecone, click Create Index, and give it a name like Tour Data. As usual, we'll choose the text embedding small model from OpenAI. We stick with the starter free plan and hit Create Index. Alright, now that our new Pinecone index is set up and ready, back in n8n, open your Pinecone vector store node, make sure it's pointing to our new index toward data, and that the Pinecone API key and environment match the ones we just used. This keeps everything in sync. Now we're going to test embedding the sheet file and pushing it to Pinecone. But, as expected, we get an error. That's because our default data loader node tries to read the downloaded file as a binary, but it doesn't support sheet formats like XLS or XLSX. To fix this, we first need to change the input type. Change the data loader's input type from binary to JSON. This tells the loader, hey, expect structured data. But right now, our file is still in binary format. So next, we'll convert the file to JSON. To do this, let's add an extract from file node right after the Google Drive node. We then choose conversion type extract from XLS or XLSX because we know this file is actually an Excel spreadsheet underneath. Now hit test step. And awesome. We successfully converted it to JSON. This JSON contains 100 items, which matches the number of rows in our spreadsheet. Now that we've converted the Excel file into JSON successfully, let's take a quick look at what this data actually looks like and how it works behind the scenes. What's actually inside this JSON? It's a list of objects, and each one represents a row from your spreadsheet. Imagine you're looking at a table of tour packages. Every row becomes an object, and every column, like tour name, price rating, becomes a key value pair inside that object. So instead of a flat table, you now have a structured format that's easy for machines to understand, kind of like a digital filing cabinet. It's still the same info, just reshaped into a tree-like format that we can now work with in the next steps. Now that we've converted our file into JSON format, it becomes the input for the default data loader node, just like it expects. Alright, everything's set, connected, and configured. Go ahead and run a test. No error this time, which is great, but let's take a look inside Pinecone to see what actually got stored. It only saved some tiny meaningless chunks of data. Why did this happen? Because unlike our document from the previous video, which was full of raw, readable text, this JSON is more like structured code, and the data loader has no idea which part of it holds the meaningful content to embed. It's like trying to summarize a spreadsheet full of formulas without knowing what any of the cells actually mean. To fix that, we need to reformat our JSON before loading it. Think of this step like prepping your ingredients before cooking. We're cleaning up the data so Pinecone can understand it properly. So to fix this, let's add a code node right after our JSON output. In the code block, let's add a few lines of code. Basically, what we're doing here is reshaping the data into a format the AI can actually understand and embed properly by combining all the values from each row into a single readable text string. Go ahead and hit test step. You'll understand exactly what the code is doing once we see the output. We've hit a memory error. That's because the workflow used up its temporary memory, which can happen when processing large files. No worries. Just clear the memory or restart the workflow, then run the test again. Alright, now that the test runs successfully, take a look at the output. Each object, which used to just be a structured row from the spreadsheet, is now transformed into two clear parts. A content field. This is one long text string that combines all the rows values into a readable sentence or paragraph. And a metadata field. This keeps the original row structure, so Pinecone can still reference every key value pair later for smarter search. This gives us the best of both worlds. A clean, embeddable text string the LLM can understand, and the full metadata context to power accurate search and filtering. Now that our data is cleaned up and ready, let's pass this into the Pinecone vector store. First, drag the content field into the data field of the data loader node. This tells Pinecone, here's the actual text to embed. To make this even clearer, I copied this content into a document. Take a look. It now reads like a short, structured paragraph. This means we can now treat each row like a mini document. And that's the key. Once a row becomes readable text like this, we can apply RAG just like we did with full documents, and chat with it easily using semantic search. But text alone isn't the whole story. We also want to keep the original context of each row for smarter filtering and more accurate answers. That's why next we pass the metadata field into the metadata section of the data loader node. This lets Pinecone store not just the embedded text, but also all the extra info tied to that row, like category, rating, or destination. This keeps all the original row info linked to each embedded chunk, so Pinecone can use it later when searching. Next, let's quickly review our text splitter settings. We'll leave the default splitter in place, but switch the format to Markdown. Why Markdown? Because our text includes line breaks and structured data, and Markdown formatting helps preserve that layout in a way that's easier for AI to read and reason about. Alright, before we run the test, let's delete the old Pinecone index, the one with the bad or incomplete embeddings, and create a brand new one, just like we did before. Once it's ready, point your Pinecone node to this new index. Now hit Test Workflow to embed the clean sheet data into Pinecone. And just like that, the workflow runs without errors. Our new Pinecone index now contains 100 clean, searchable records, each one built from a row in the spreadsheet, with both the readable text and the full metadata. This means Pinecone can now understand each row semantically and help our AI chatbot find the right answer based on meaning, not just keywords. Let's take a peek inside the index to confirm. You'll see that each record contains a content field, plain text for embeddings, and a metadata field, the original row structure for rich context. Awesome! We've now fully transformed our sheet into an AI-readable knowledge base. Now that Pinecone has the sheet data embedded and ready, let's test it out using the same chatbot setup we used for documents. Since we duplicated the original RAG workflow, most of it is already in place. We've got our chat trigger, our question and answer chain, and the OpenAI chat model to generate responses. What we need to double check is the Pinecone vector store retriever node 1. Make sure it's pointing to the new Tor data index we just created. Confirm it's using the same embedding model we used earlier, text embedding small. Once that's done, open up the chatbot and let's run a real test. Let's try asking a question based on the sheet data. The chatbot responds with a relevant answer, pulled directly from the Tor data table we embedded. It works. Our bot can now chat with structured table data as if it were reading from a document. Finally, let's activate the workflow to make it production ready. That way we can test it directly from a live website, just like a real-world user would. Alright, we've confirmed that our chatbot can now answer questions based on structured sheet data. But let's take it a step further. What if we want the chatbot to respond with images too? Let's say each row in our spreadsheet includes a URL to an image, like a tour photo. Imagine your bot not only answers questions, but also shows users a visual preview, like a tour photo or product image. To make that work, we simply add a new column to the sheet for image URLs, one for each row. Then we create a new pinecone index for the updated data. Give this index a clear, meaningful name, like tour data with images, or simply name it tour image. Then go ahead and finish creating the index, just like we did earlier with the original data. Once that is done, we are ready to continue the process. But before moving forward, make sure to update your pinecone vector store node to point to the new index that includes the image URLs. That way, all the new content, including images, gets used when the chatbot generates responses. Now, let's run the workflow again to push the updated table into the new pinecone index. Once it's done, we'll check the index to confirm that each record's embedded text now also includes the image URL, so the chatbot can reference it directly when generating responses. Awesome! Now each record's embedded text includes the image URL. That means we're ready to test the chatbot with this new updated data. But before we do that, make sure your question and answer workflow is synced with the new pinecone index, the one that contains the image enhanced entries. Once that's set, let's jump into testing. We hit save. And now it's time to test everything in action. I'm going to use the travel website I prepared in the previous Chat with Document video. You can find a link to download the HTML template in the video description. Make sure the webhook URL inside the script block of the web page matches the chat trigger webhook URL from your current n8n workflow. That's how the chatbot knows where to send and receive messages. Alright, let's load up the website by simply double-clicking on the HTML file. It'll open right in your browser. Then go ahead and ask a question, something that pulls from the table data we just embedded, like show me a list of the top 5 rated tours, and include their names, destinations, and images. Let's see how the chatbot responds. And just like that, you get a smart, human-like answer, plus the image pulled straight from the sheet. It's fast, accurate, and way more engaging for users. Now your chatbot isn't just functional, it's visual, helpful, and production ready. So far, we've built a chatbot that works beautifully inside a website. But let's be real, not everyone uses websites to ask questions. A lot of users prefer messaging platforms like Telegram. It's fast, mobile-friendly, and always in your pocket. And what if we could go even further and let users send voice messages too? We'll show you how to build a Telegram bot that responds to both text and audio messages. We'll start by adding the Telegram trigger node. This listens for every message sent to our bot. Under the trigger section, choose on messages, so the workflow runs every time someone sends a message. Now, we need to create a new credential for this Telegram bot. To do that, we'll first create a brand new Telegram bot and grab its access token, then paste that here to connect n8n to our bot. To do that, we'll create a Telegram bot using BotFather, Telegram's official tool for managing and creating bots. Open Telegram, search for BotFather, and start a chat. Or you can go to this URL to open BotFather. Inside the BotFather chat, you'll see a list of commands by clicking on this button. Go ahead and choose New Bot to create a new bot. Then follow the prompts to give it a name and a username. Just make sure the username ends with _bot. Once that's done, BotFather will give you an access token. Before we start using this bot's access token in production, let's take a quick look at the bot's username. This Telegram bot's username is what your users will interact with in production. Once your bot is live, you can simply share this bot link and anyone can chat with it directly from their Telegram app. No extra setup needed. It's like giving your business a 24/7 AI assistant right inside the apps your users already use. Alright, back to the message. Copy this token and paste it into your Telegram triggers credential setup in n8n. Hit save, and we're connected. Next, let's add the AI agent node. This will handle all incoming messages and generate responses using an LLM. For the AI model, we'll use Chat OpenAI, but you can use any model that supports chat-based prompts. Now let's move on to testing the Telegram trigger. Go ahead and hit Test Workflow. We got an error. It is saying we can set listen for test executions while the workflow is in active mode. No problem. Just toggle the workflow to inactive, then hit test workflow again. Next, let's test it out by sending a message to our Telegram bot, just to make sure the trigger is working in real time. I've got the Telegram bot open side by side with n8n, so we can visually follow what's happening. Alright, I'll send a quick message, and yep, the Telegram trigger picks it up instantly, then passes it to the AI agent node. But here's the catch. The AI agent node throws an error. Why? Because by default, it expects input from a chat trigger, not a message coming from Telegram. So to fix this, we need to manually tell the AI agent what to use as its prompt. In the prompt source option, change it from use chat inputs to define below. Now we can drag in the text from the Telegram message, and we're good to go. This tells the agent, hey, use this Telegram message as your prompt input. Let's try again. I'll send another message to the bot. This time, no errors. The AI agent successfully reads the Telegram message, processes it using the OpenAI model, and gives us a smart response based on that input. Alright, now let's see how our Telegram bot handles an audio file sent as a document. Instead of using Telegram's built-in voice message, which we'll handle later, this time we're uploading a regular audio file as a document attachment. Send the file to your bot. We'll watch how the Telegram trigger picks it up. Now we got an error from the AI agent again, and that's expected because right now the AI agent is still looking for plain text from the Telegram message, but this time we sent an audio file. So the message doesn't have a message text field anymore. Instead, the audio data lives inside the message, and we need to handle that differently. So let's fix it. We'll add a switch node right after the Telegram trigger to check whether the message is an audio file and route it accordingly. In the switch node, since sending an audio file returns a file ID, we'll check if the incoming message contains that audio file ID. This lets us detect when someone uploads a recording instead of typing. We'll use the exists operation. This checks whether the audio file ID exists in the incoming message. That tells us the user uploaded an audio recording, not a regular text message. Let's name this route audios so we can keep things organized. If the workflow follows this path, it means we've received a Telegram audio file. But here's the thing. The AI agent node only works with text prompts, so we need to convert that audio into text first. Let's do this in 2 steps. First, get the actual audio file using the Telegram node. The Telegram trigger only gives us a file ID, not the file itself. So we'll use a Telegram node set to get a file action. Hit execute previous node to preview the incoming data. Then drag the file _ID into the file ID field. Test the step, and now we've got the actual audio file as output. Alright, now that we successfully retrieved the audio file from Telegram, it's time to turn that voice message into actual text. This is the key step that lets our AI understand what the user said, not just what they typed. So let's add a new OpenAI node to our workflow. In the action dropdown, select Transcribe a Recording. Make sure your OpenAI credentials are connected. By default, the input field is set to look for a file named data, and that matches perfectly with the audio file we just retrieved from Telegram. So you don't need to change anything. The node already knows where to find the audio. Let's go ahead and hit test step to see the transcription in action. Boom! Here's the full transcription. This is the exact sentence that was spoken in the audio file, now perfectly converted into plain text. Just a test. Now we've got something the AI can actually work with. At this point, we've taken an audio file from Telegram, converted into readable text, and we're ready to send that to the AI agent. But before we do that, we need to make sure the AI agent picks it up properly. By default, it's still looking for message text, like in regular Telegram messages. So let's remove that old message reference in the prompt field. This becomes the new prompt for the AI agent. Since the prompt field is set to detect text input, it matches perfectly with the transcription we just generated. No extra setup needed. The AI agent is now ready to process voice inputs as natural language. Now earlier, we handled text messages without a switch node. The Telegram trigger passed the message directly into the AI agent node. But now that we've added a switch node to handle audio, we need to update our workflow so it also knows how to handle text messages correctly. Let's send a regular message again in Telegram, and you'll see it doesn't follow any route. The switch node doesn't know what to do with it. That's because it's only checking for an audio file ID. And since this is just plain text, the audio route throws a red flag. To fix it, we add a second condition. This time, we check whether the message contains a text field. Just drag in the message text value, and again, choose the exists condition. This will let the switch node detect when the input is a regular text message and send it down a new route. Let's label this route clearly. Something like text. Alright, now our workflow can handle both audio messages and normal text messages. Let's route them to the same AI agent node. Whether it's a message typed in or spoken out loud, we want both types to end up as a prompt for our AI model. So let's connect them to the shared AI agent node. Now let's fine-tune the text path so it matches the format we're already using for audio messages. Right now, the AI agent node is expecting the prompt to live under a simple text field, which works great when we transcribe an audio message. But when we send a normal text message, the data comes in under message.text. That means the structure is different and the agent won't recognize it. So here's how we fix it. Add an edit fields node right after the text route in the switch node. In this node, we create a new field called text, then set its value to the message.text. This pulls the text out of the message object and flattens it so it sits at the top level, just like the audio transcription. Hit test step and you'll see now we have a clean text field on its own, ready to be passed into the AI agent. With this change, both text and voice messages now follow the same format, and our chatbot can handle them with zero confusion. Now let's take this chatbot to the next level by giving it memory. Right now, our bot can respond to individual messages, but it has no memory of the previous conversation. That means every question is treated like a blank slate. To make it more natural and human-like, we need to help it remember context, so users can ask follow-ups and continue the conversation smoothly. To do that, we'll add a simple memory node. But when we test it, we get an error. What's going on? Well, here's why. By default, the simple memory node expects to work with a chat trigger, which has built-in session tracking through things like session ID, but we're not using a chat trigger anymore. We're handling input from Telegram and passing text directly to the AI agent. So here's how we fix it. In the simple memory node settings, change the session ID to define below. For the key field, we're setting it to message.from.id. This tells the memory node to identify each user based on their unique Telegram ID. That way, the AI can remember past messages separately for each user, even if multiple users are chatting at the same time. It's like giving every conversation its own private memory space, so the AI can respond more naturally with context that sticks. You'll also see a setting called context window length. This controls how many past interactions the memory should keep. By default, it's set to 5, meaning the AI will remember the last 5 messages in the conversation. That's usually a sweet spot, not too long to overload the model, but just enough to keep the conversation coherent and natural. So we'll leave it as is. Now, in the AI agent node, hit test step again. No more errors. And now our Telegram chatbot has short-term memory, perfect for follow-up questions and natural back-and-forth conversations. Now that our Telegram bot is fully connected to the AI agent node, just like we did when chatting with document or sheet data via a website, we need to let the AI agent search and retrieve answers from Pinecone. This time, we'll use something a bit different. The Vector Store Question Answer Tool node. Why this node? Because it acts as a smart helper for your AI agent. It searches your vector database and uses another LLM like OpenAI to help reformat the question and polish the answer for better results. It's like giving the AI a second brain that specializes in understanding your structured data. Give it a clear name, like Tor Data Assistant, and in the data description field, add a summary of what this data is like. This index contains Tor package data, including ratings, destinations, and image URLs. This helps the LLM better understand the context of the answers it's generating. Alright, now that our tool node knows what kind of data it's working with, let's connect it to the actual Pinecone vector database so it can start searching that information in real time. Be sure to select the Tor image index we created earlier and use the OpenAI embedding model just like before. And now, the cool part, add an LLM directly to this node as well. We'll use Chat OpenAI. This gives it an extra layer of smart reasoning before sending the result back. It searches, generates, and formats the answer like a pro, based on your Pinecone data and the extra context we gave it in the answer questions node. That combo helps the AI return more accurate, natural, and helpful responses, which are then passed back to the main AI agent for delivery. Now that we've connected the AI agent to memory and the vector store tool backed by Pinecone, there's one more piece that really brings it all together. We need to tell the agent what role it's playing and how it should respond. That's where the system message comes in. Let's go ahead and add it to the AI agent node. This is where we give your agent clear instructions, like a mission briefing. Here's a simple prompt you can use. You can find this under the description of the video. This tells your AI what kind of assistant it is, where to find its information, and how to respond to users in a natural way. This message helps the AI stay consistent and makes it feel like a real conversation. Alright, we've got our AI generating helpful answers. Now it's time to send those answers back to the user on Telegram. Add a new Telegram node to your workflow. We choose Send Message and wait for response action. Set the operation to Send Message. Here's what we need to send the message back to the user. First, the chat ID. That's how Telegram knows exactly which conversation to reply to. You can get it from the Telegram trigger. It's under message chat.id. Every time the Telegram trigger receives a message, it returns a full data object. And inside that is the chat.id. This value is crucial. It tells us which user or which conversation we're replying to. Without it, Telegram wouldn't know where to deliver the message. Next, we need to tell Telegram what to say. That's the reply text itself, and it comes directly from the AI agent's response. Just drag the output value from the AI agent node into the text field. And that's it. Telegram now knows who to send the message to and exactly what to say. Your AI voice assistant is ready to reply, instantly and intelligently. Now let's test it out. Go ahead and hit Test Workflow to activate the Telegram trigger. Then open your Telegram app and send a message to your bot. Watch the magic happen. Telegram trigger will listen new messages, then the AI processes and Telegram sends the reply. Alright, your AI voice assistant just replied with an output generated from real data in your sheet. The answer is accurate, personalized, and delivered instantly. Each field in the response, including the Tor name, price, rating, and even the image URL, was pulled directly from the Tor data table. It's like having a smart assistant that knows your spreadsheet inside and out. Next, let's customize the workflow so that when a user sends an audio question, the bot replies with an audio response instead of plain text. Right now, whether the user sends a message by typing or by recording their voice, the response is always sent back as text. But that's not what we want. So let's fix it by adding a switch node to separate the flow into two clear paths, one for text prompts and one for audio prompts. This way, if a user sends an audio file, we'll reply with an AI-generated voice for a more natural and interactive experience. But before we set that up, let's quickly remove the default response text from n8n that's currently being sent. This will clean up our replies before we start customizing the output. Right now, here's what happens. No matter what the user sends, a text message or an audio file, the Telegram bot always replies with a text message. And not just that, at the bottom of every reply, there's also a default message from n8n that looks a bit out of place. It's not ideal for a polished user experience, especially if we're building a real production-ready AI assistant. So next, let's clean that up. In the Telegram response node, we'll make a quick tweak. Just add a new field, then select Append n8n Tribute, and simply disable this option. That's it. Now, when the user sends a message, you'll see only your AI's response. And that default n8n footer, gone. A cleaner, more professional chat experience. Awesome. Right now, when our bot responds with a message that includes an image link, Telegram doesn't preview the image. So let's fix that. Head back to the Telegram response node, add a new field, and look for Disable Web Page Preview. Make sure it's not selected, because we do want the image preview to show. Now, test the workflow again. Ask for a tour that includes an image. Boom. The message now includes a preview image right inside Telegram. Much better. Next, let's enhance the experience even more. We want to reply with text if the user types, but respond with audio if the user sends a voice message. To do this, we'll update the switch node just like before. We check if the Telegram trigger returns a message. If it does, we know it's a text route, and in that case, we just send a text response back. Alright, but what about audio messages? Let's test by sending an audio file. In the Telegram trigger's output, we can see it returns a message .file_ID. That's our signal for the audio route. If that file ID exists, we know it's a audio input, and now we want to respond with audio, not text. We'll take the AI agent's text output and convert it into speech using OpenAI's text-to-speech tool. Add a new OpenAI node, then under Audio Actions, choose Generate Audio in the text field, drag in the text output from the switch node. You can even choose from multiple voices, whatever you like. You can even adjust the voice style and speed to match your brand or tone. Hit Test Step, and now we have got an audio file. Now let's send that audio back to the user. Add a new Telegram node and set the operation to Send Audio. Then just like before, drag in the chat ID from the Telegram trigger so we know where to reply. And don't forget to enable the binary data option since we're sending raw audio. Alright, hit Test Step. And just like that, your bot responds with a real voice. It seems like you're testing the system. If you have any questions about travel or tours, feel free to ask. Now let's update our switch node logic just a bit. Currently, we've labeled the audio route as voice, but to stay accurate, let's rename it to audio since it's handling uploaded audio files. Next, let's handle a new case, actual voice messages recorded in the Telegram app. So go ahead and record a sample voice note in the bot. Back in n8n, take a look at the data Telegram returns. You'll notice it looks similar, but this time, the file ID is found under the voice key instead of audio. So let's add a new route in our switch node and label it voice message. In this new condition, we'll check if message.voice.file_ID exists. If it does, we know this was a voice recording, and we will handle it just like audio route. Now that we've added the new voice message route, Let's build out the logic to handle it, just like we did for uploaded audio files. First, we'll drag in a Telegram node and set the operation to get file. This will take the voice's file ID from the voice message and retrieve the actual audio data from Telegram servers. Just drag the file _ID field into the file ID input. Hit test step, and you'll see the full audio file appear in the output. Perfect. Next, we'll transcribe that voice into text using OpenAI's Whisper model. Add an OpenAI node, and under Audio Actions, choose Transcriber Recording. Make sure your OpenAI credentials are added. And by default, the input will look for the binary audio data which we just retrieved. The bot gives us the full transcribed text from the voice message. Now we're ready to pass that into the AI agent, just like we did with regular audio files. Now let's connect the final piece of the puzzle. We go back to the switch node and update it to handle voice messages. Just like before, we'll add a new condition. Check if voice.file_ID exists. If it does, we know this message came from a recorded voice note, not text or uploaded audio. Let's name this new path voice, so it's clear what we're routing. Now, just like the previous audio route, we connect the voice path to the same flow. Basically, after the AI agent node processes the input and returns an output text, we pass that text into a switch node. When the switch detects a voice file ID from the Telegram trigger, it knows this is a voice route, so it sends the output text to OpenAI's text-to-speech node to generate a natural-sounding audio response. Finally, pass that audio result to the Telegram send audio node, so your bot can reply to voice messages with a voice of its own. It feels like talking to a real assistant, no matter how the user reaches out. Finally, let's run a full test. We'll send a recorded voice message to our Telegram bot and see how it handles everything end-to-end. What's included in the island getaway tour and how much does it cost? Before we listen to the response, let's keep an eye on our true data table just to make sure the bot replies with the correct information. The Island Getaway Tour includes a stay at a 5-star hotel, all meals, and travel insurance. It costs $1,080.07. Sounds like a wonderful experience. And boom, the bot replies with a realistic voice, smartly answering the question and pulling the exact info from our table data. Seamless, accurate, and production ready. As a bonus, I've got something special for you. Instead of paying for expensive text-to-speech services like OpenAI's API, I've already deployed a new text-to-speech API powered by OpenAI quality voices, but the cost is on me. And right now, I'm opening this up completely free, including the API and the private community. Just join the community, also free, and you'll get instant access to the API details, docs, and voice vibe list for testing. Try it out, give feedback, and help shape what we build next. All right, ready to test it out? Instead of using OpenAI's built-in text-to-speech, we're going to plug in our custom API to handle voice generation. For both the audio and voice routes, we'll replace OpenAI's text-to-speech with a simple HTTP request node. This node will send a post request to the custom API endpoint. You'll find the API URL in the video description. In the request body, we're going to send 3 simple parameters. First is the text. This is the actual content you want to convert into audio. Second is the voice. You can choose from a variety of voice styles I've listed in the GitHub repo, like Alloy, Nova, or Coral. Simply choose one from the list to test it out. Pick the voice that fits your brand or use case best. And third is the vibe. This controls the emotion or tone of the speech. You can choose one from the list of vibes I've prepared for you. Things like friendly, calm, or even pirate. Just head to my GitHub repo to see the full list. Now hit the test step to make sure the API is working and returning an audio file. Awesome. We've got our voice data. Next, we send that audio to the Telegram send audio node to deliver it right back to the user. Also, don't forget, connect the audio route to this new API request as well. Now both the audio and voice paths are powered by our custom text-to-speech API, and they're ready to respond with natural expressive speech. All right, let's run a final test to hear it in action. Let's go ahead and hit Test Workflow to activate the Telegram trigger. Then send an audio file to the bot and see how it works in action. Sit back and listen. Your AI assistant is now speaking back using your custom voice and vibe. What is included in the Desert Adventure Tour? The Desert Adventure Tour in Egypt includes some great perks. You'll enjoy a stay at a 5-star hotel, local transportation, and airport transfers. Sounds like an exciting adventure. And just like that, you've built a fully functional AI voice agent with n8n. Just toggle the workflow to active, and it's ready to run in production, live and listening 24/7. Whether it's on Telegram, your website, or any platform, you now have a smart, scalable support bot powered by your own data. If you found this helpful, don't forget to share it, drop a comment, or join our community, where we build powerful AI tools together. Thanks for watching, and I'll see you in the next one. Imagine creating high-quality videos from just an image. No GPU rental fees, no daily limits, and no credit burnouts. In this video, I'm going to show you how to run FramePack locally to turn still images into stunning videos, completely free and on hardware you probably already have. This tool only needs about 6 GB of VRAM, making it super accessible for builders, creators, and small teams. And the results, honestly, they rival or even beat what you'd get from some of the biggest paid platforms out there. Whether you're making faceless YouTube videos, social media ads, or enhancing product visuals, this might just change your workflow forever. We'll start by taking a quick look at the FramePack GitHub page, where you can preview some of the generated videos and get a feel for what's possible. The demo examples here show off cinematic transitions, smooth movements, and stylized motion, all from a single image prompt. Now let's jump into how to run it locally. Whether you're using Windows, Linux, or Mac OS, the process is surprisingly simple. Before we dive into setting up the environment, let's first confirm that your GPU is ready and available. Because FramePack uses a little GPU magic to make the image-to-video process fast and smooth. On Windows or Linux, it's super easy. Just open your terminal or command prompt and type NVIDIA Semi. This command will show you a list of all the NVIDIA GPUs available on your system, along with details like memory, usage, and driver versions. If you see a nice table pop up showing your GPU, you're good to go. If not, you might need to install or update your GPU drivers first before continuing. Once you've confirmed that your GPU is detected, now we can move on to setting up the environment to run FramePack. We'll set up an isolated environment. You can use either Conda or pipenv to manage your environment, whichever you're more comfortable with. In this tutorial, I'll be using Conda because it's beginner-friendly and super reliable when working with GPU tools like PyTorch. All the commands and setup steps are available inside the Image to Video course on 02 Launch Premium. If you're a member, just head there and copy-paste the snippets to speed up your setup, whether you're on Windows, macOS, or Linux. All right, let's jump back into our walkthrough. Once you've got Conda installed, the first thing we'll do is activate it in your terminal. After that, we'll create a new environment specifically for this project. And this is important. By isolating our dependencies in a clean environment, we make sure nothing conflicts with other projects or system libraries. Think of it like setting up a dedicated workshop. No distractions, no mess, just the exact tools we need to run FramePack smoothly. Once your environment is ready, let's activate it. You just run conda activate followed by the name of the environment we created. Once it's activated, you'll notice the environment name showing up at the start of your command line. That's how you know you're now inside your new workspace. This new environment is clean and completely isolated, meaning anything we install here, like libraries and dependencies, will only apply to the FramePack project and won't mess with any other setups on your machine. Now let's set up the project itself. We'll create a new folder just for FramePack. After that, we'll navigate into the folder and clone the FramePack code from GitHub. Once the project is downloaded, we simply cd into the new folder. Before we can start using FramePack, we need to install all the required libraries. Just follow the instructions from the official GitHub guide. It's super simple. This step might take a few minutes, so grab a coffee and let it do its thing. Once the installation finishes, it's time for the fun part, running the demo. We'll launch the Gradio interface by running the demo gradio.py file. The very first time you launch it, FramePack will automatically download the necessary models and checkpoints in the background. So again, be a little patient, let it finish everything it needs. After it's done setting up, you'll see that FramePack is now running locally, and you can access the web UI from your browser using the local URL it gives you. But there's one small problem. If you're using a rented cloud GPU or want to access it from a different device, you won't be able to reach localhost directly. To fix that, we simply rerun the demo file, add a -- share flag at the end. This tells Gradio to generate a public link, a shareable URL that's live for 72 hours and can be accessed from anywhere. Alright, once you run it with -- share, you'll see a brand new public link appear. Just copy that URL, open it in your browser, whether you're on a laptop, a phone, or even a tablet, and you're ready to start creating magic with FramePack. After loading up the URL, you'll see a clean user interface built with Gradio. This is where we can easily interact with the FramePack project without touching any code. First, let's drag an input image into the upload box right here. It can be any photo you want to animate. A landscape, a city scene, anything you imagine. After you drop it in, give it a few seconds to fully load. Now, before we generate anything, there's one setting we'll tweak. Let's uncheck the Use Tcache option. Now, what exactly is Tcache? It stands for Teacher Cache. And here's how it works. The teacher model inside FramePack is very smart, but also very slow. If you ask it to create a moving video from your image, it could take minutes or even hours to fully think through everything from scratch. So instead of forcing the computer to think hard every time, FramePack lets you run it once, save the smart hints it generates, like movement directions, noise cleanup, motion details, into a storage box called Tcache. Then next time, instead of thinking from scratch, it just reads the smart hints from Tcache and speeds up the video creation dramatically. Pretty cool, right? But here's the catch. Because it skips some of the heavy thinking, the quality of videos created with Tcache is usually about 90% as good as running it fully from scratch. Sometimes, you might even spot weird artifacts, like characters with extra arms or motion that looks a little unnatural. That's why, for this first local test, I'll leave Tcache turned off. We want the best possible quality for our generated videos, even if it takes a little longer. Alright, leave the other parameters at their defaults. FramePack can generate videos up to 1 or 2 minutes long. But keep in mind, longer videos take much more time. For now, I'll keep it simple and leave the video length around 5 seconds. Perfect for quick testing. Finally, give your image a creative prompt. Then hit Start Generation and let's watch FramePack bring your image to life. After about 5 minutes on my NVIDIA RTX 3090, the video finished rendering. Of course, the processing time will depend on your GPU. The better the GPU, the faster the results. But even with lower-end cards, it's still completely doable. And what we get is a 5-second video, generated entirely from a single image. The quality, honestly, pretty impressive. It also depends on the prompt you provide. So be creative with it. The better the prompt, the more expressive and dynamic your result can be. And once it's done, you'll see a download button. Just click it to save your video and use it however you want. Simple as that, whether it's content creation, social media, storytelling, or even AI-powered ad creatives, you're good to go. Unlimited downloads, more engagement, and all for free. You're all set to shine. we've successfully run FramePack locally and turned our first image into a video. A huge step. But there's still one big limitation. It's not yet connected to the outside world. To integrate with platforms like n8n or Telegram, or to automate the entire process remotely, we need to take things further. Setting up a back-end server, handling webhooks, and creating an endpoint that can receive requests from anywhere and trigger GPU-powered video generation. All of that is covered in the next phase, exclusively inside the n8n Launch Premium community. So if you're already a member, head there now to unlock the next steps. If not, now's the perfect time to join and take your AI automation to the next level. If you've ever tried generating high-quality videos from images using advanced models like FramePack, you've probably hit a major roadblock. Hardware limitations. Most users don't have access to expensive GPUs at home, and trying to run these heavy models on a standard machine can overheat your computer, slow everything down, or even cause crashes. That's where Google Colab comes in. In this video, we're going to walk through how to run FramePack on Google Colab, using Colab Pro to generate stunning AI videos from a single image. Why Colab Pro? For just around $10 a month, you get access to powerful GPUs and high RAM, enough to run not just FramePack, but also multiple video generation models and other heavy AI tools without frying your laptop. So if you haven't already, take a moment to subscribe to the Colab Pro plan. Once that's set up, we're good to go. After subscribing, head over to the main page of Google Colab and create a new notebook. Give it a meaningful name so you can easily find it later. Now, if you're a member of n8n Launch Premium, just jump into the classroom and find the lesson titled Run FramePack on Colab Pro. Inside that lesson, we've already provided the code you need. Just copy and paste it directly into your new notebook. If you're not a premium member, no worries. You can simply follow along and type the code manually into your notebook. It's all straightforward. Before we run anything, let's tweak a key setting. Go to Runtime, change Runtime Type, and select the L4 GPU. This GPU gives us excellent computing power and high RAM, perfect for heavy video models like FramePack. Once selected, hit Connect to apply the changes. Next, you'll need to sign up for a free ngrok account and grab your unique ngrok token. Paste that token into the section of the Colab file where it asks for it. Then toggle the setting to activate the F1 model. This is the latest version of FramePack, and it offers much smoother motion and overall better video quality. What this setup does is expose FramePack via a public URL so you can access the UI from anywhere. Pretty cool. Alright, now comes the fun part. Just hit Run on the notebook. Colab will start downloading the FramePack model and all its dependencies. After a few moments, it'll give you a public ngrok URL. Open this URL. And boom, you're now looking at the FramePack user interface, right in your browser. From here, upload an image of your choice, type in a creative prompt, and decide how long you want your video to be. In this case, I'll generate about 8 seconds of video. Then hit Start Generation. Go grab a coffee and come back in 10 to 15 minutes. And there you have it. A beautiful, high-quality 8-second video generated entirely from a single image using just Google Colab and FramePack. No fancy PC required. This is just the beginning. Once you've got this workflow down, you can experiment with different images, prompts, or even try combining models. FramePack is powerful, and Colab Pro makes it accessible to everyone. Don't forget to save your notebook for future use and keep exploring what's possible with AI video generation. And just like that, you've created a stunning high-quality video from a single image using cloud GPUs and open source tools. This is just one of many AI video we explore inside the n8n Launch Premium community, where we take the most advanced tools out there and make them simple, accessible, and actionable for creators, developers, and automation enthusiasts. Inside the community, you'll get access to unlimited premium APIs, including GPT 4.1, realistic text-to-speech voices with multiple moods and tones, speech-to-text transcription, text-to-image with Flux and OpenAI's Vision API, and a whole lot more. It's a full-stack AI toolkit ready to plug into your projects without limits. If you found this tutorial helpful, make sure to check out the rest of the lessons in the AI video series. And if you're ready to take your AI automation skills to the next level, join us inside the community and unlock everything: the tools, the templates, the support, and the momentum. Your next automation breakthrough might just be one lesson away. In this tutorial, I'm going to show you how to build a powerful, fully automated workflow that turns a simple product photo into multiple scroll-stopping, ad-ready visuals using n8n, Telegram, and OpenAI. We'll start by sending a product photo through a Telegram bot, then automatically analyze that image with OpenAI's vision model to understand details like lighting, composition, and camera angle. From there, the workflow generates creative ad concepts and uses OpenAI's image generation API to bring those ideas to life, all without you lifting a finger after setup. The final AI-generated ad images are sent right back to the Telegram chat, ready for review or posting. And here's the cool part: by adjusting the prompt just slightly, you can even generate text overlays on your product image, making your creative outputs more engaging and perfectly suited for ads. Toward the end, I'll also show you how to polish your workflow to adding sticky notes so it's clean, professional, and ready to share, reuse, or even sell as a production-grade solution. Let's dive in and build it together. After walking you through the demo, let's dive in and start building the actual workflow. We'll begin by creating a brand new workflow inside n8n. The first step is setting up a Telegram trigger node. This will listen for all incoming messages from users. But before this node can do its job, we need to connect it to our Telegram bot by creating a credential. So let's go ahead and create a new Telegram credential. To do that, we'll follow the official n8n documentation to create a Telegram bot and retrieve an access token. I've already completed this step, so I've got a fresh bot and a valid access token ready to go. Now, let's plug that token into the Telegram trigger node and give the credential a clear, meaningful name. Next, let's test our new bot connection. We'll click the test step and then head over to the bot and either send a message or simply hit start. Immediately, the Telegram trigger pulls in the new message. From now on, anytime a user sends a message, this trigger will automatically update, which is perfect for processing the next steps in real time. Now that the trigger is working, we'll drag in another Telegram node, this time the get file node, because in our use case, we want to retrieve product photos sent by users. To make sure we're pulling the correct image, we'll test the trigger again, but this time, we'll only send a photo. Once we do that, Telegram sends back a list of file objects, each with a different resolution. We'll select the highest resolution version from that list and pass its file ID into our get file node. Then hit Test Step button. Alright, make sure to select the right Telegram credential before testing this node. Go ahead and click Download. We can now see the actual photo file that was just sent by the bot. Alright, perfect. Now, to start designing ad creatives, we need to understand the product image itself. That includes analyzing image types, camera angles, lighting styles, and background details. This step is crucial. The better we understand the original photo, the more relevant and high quality our creative output will be. To do this, we'll use the OpenAI Analyze Image node. First, fill in your OpenAI API credentials and choose a model. GPT-4o works well here. Then, input a prompt asking the model to extract key details from the image. Such as style, lighting, background, and camera angle. Also, make sure the node is set up to accept a data file as input. But before we can test this node, we need to convert the Telegram file into a proper image format. By default, Telegram returns files with a MIME type of octet stream, which OpenAI Vision can't process. So we'll add a function node to convert the file type to JPEG. You can grab the conversion code from the community lesson and paste it in. And just like that, the file is now ready to be analyzed. Let's test the OpenAI node again. And awesome! We now have a detailed analysis of the image's properties. Next up, we want to generate creative photo prompts based on the original image. But before doing that, we'll insert an edit fields node to specify how many creative outputs we want. For this demo, we'll go with 2. Now we'll combine the analysis and the desired output count and pass them into an AI agent node. For the user prompt, we drag in the photo description from the analysis. Then for the system prompt, we paste in a prompt template from the community. This tells the agent exactly how to generate high-quality, engaging creative photo ideas based on the original. We also define the number of creative outputs, in this case 2. And provide an example output format to guide the model. Make sure to select a language model, like Chat OpenAI, and toggle the output formatting option so we can set up a proper output parser. To ensure consistency, we tell the parser to expect a JSON object with a list of prompts. Once tested, the AI agent returns a clean output object containing all our creative prompts. Now we need to split that list into individual prompts, so we add a split out node to separate each item. Once everything is set, let's hit the test step to see how it works. Alright, the AI agent returns a single field called output, and inside it, we have a list of creative prompts. These follow the exact structure we defined earlier in the output parser using our JSON example. This split out node helps us extract just the list of prompts from inside the output object. Removing the outer wrapper, we can clearly see that we're now working with a clean array of prompt strings, ready to be processed one by one. With our creative prompts in hand, it's time to fetch the original photo again, using another Telegram getFile node. Just like before, we extract the file ID from the trigger. Alright, select your credential, then hit the Test Step button. Since we have 2 branches from the split prompts, Telegram will fetch the photo twice, once for each flow. Now each flow includes a creative prompt in the original photo. Perfect! We're ready to generate images using OpenAI's image generation API. Before that, we need to convert the photo's MIME type to JPEG again, just like earlier. Okay, we now have 2 JPEG photos. Then we'll use a loop over items node to process each creative prompt in sequence. This loop goes through each creative prompt and its corresponding original photo, sending them to the OpenAI image generation API one by one. Inside the loop, we configure an HTTP request node for a post request to the Edit Image API endpoint. Be sure to use your own OpenAI access key and verify your account if needed to access GPT Image 1. In the request body, we attach the original image as binary data and add the creative prompt we generated earlier. The input data field name of the input will be data by default. As we mentioned earlier, to generate a creative ad image, we need a combination of the original photo and a creative prompt. Next, let's execute the previous nodes so we can grab and drag the creative prompt from the split out node. This ensures the prompt matches the correct photo in each flow. Then, we set the model field to GPT Image 1 so the API knows which image model to use. After the image generation request is complete, OpenAI responds with a base 64 encoded image string, usually found inside a specific field in the return data. To turn that into a usable image file, we'll use the Convert to File node. Now, go ahead and fill in the required fields, mapping the exact location of the base 64 string from the HTTP response. We'll see it clearly when testing. Hit Test Step, and there it is. We see a base 64 string with a specific field name in the response data. So we simply tell the Convert to File node exactly where to extract that base 64 value from the input structure. And once that's done, boom, we get a proper photo file output ready to preview. Awesome. That's one image done. But remember, we have two. So we connect the Convert to File node back to the Loop over Items node, which will repeat the process for the second prompt. Each loop generates and prepares an output image. Finally, to deliver the result, we send each photo back to the Telegram user using a Telegram send node. Select the correct credential and map the chat ID from the trigger. Don't forget to enable the binary file toggle since we're sending an actual image. Alright, finally, let's hit Test Workflow. Then in the Telegram bot, we send a new photo to the bot and watch the magic happen. The workflow is triggered, creative prompts are generated, photos are processed, and within moments, both creative photo outputs are sent back to the user. Alright, the loop will go through each prompt in original photo one at a time, generating a creative ad image for each, and sending them back to Telegram one by one. And just like that, awesome. The creative ad photo looks fantastic. To finish, let's give all our nodes meaningful names. This makes the workflow much easier to manage and debug later. Once we finish renaming our nodes, it becomes much easier to understand what each one does at a glance. The workflow is now clean, readable, and simple to maintain going forward. And for a professional touch, drag in some sticky notes to annotate each section. You can group related nodes and use different colors to make everything visually engaging. Once that's done, your workflow will look polished, engaging, and truly professional. For a final polish, you might even add a master sticky note at the top with a summary or guide for the entire workflow. Perfect if you plan to share or sell the setup. And that's it. Your creative ad generation workflow is complete. Clean, professional, and production ready. And that wraps up our creative ad image workflow. From receiving a product photo in Telegram, all the way to generating high-converting visuals with OpenAI and delivering them back automatically. Now, if you want to take this even further, here's something special. You can grab the full prompt library, the final polish workflow, and a bunch of bonus assets, structured output examples, and behind-the-scenes extras, all by joining the 02 Launch Premium community. Inside, you'll get access to this project and many more automation-ready workflows to help you launch smarter, scale faster, and bring your ideas to life with AI. Just head over to the Community Hub, and everything is ready for you to download and use right away. See you there.